All right, let me share out my screen. Okay. Welcome to week 2. We have more people here than last week, which is excellent. That is never the case. So I'm very excited. Let me pull up the screen I have up here. All right. So before we begin, does anyone have any specific questions about last week's assignments or work, or anything about this week's assignments work before I jump into my plan for this evening? Nope. Okay.
Yep. Teacher.
Hit me.
Yes, here, Kimario. Well, last week, one thing we had, where I had some problems, was assigning the proper all permissions using the
CLI.
CLI. Yes.
So if it didn't work, if I didn't get, if you emailed me or texted me and I didn't give you this response, if you tried it, it didn't work, that's totally fine. You'll never use it again in this class.
Okay.
It was a one-time deal. It was trying to show you. For some reason, the makers of the writers of this book wanted to prove to you that the CLI was a far superior. Hello, Jason's family. How you guys doing? Is a far superior way of doing things than the workbench, which is someone that is something I respectfully disagree with. So if it didn't work, it's totally fine. In your paper that you wrote, you could say something to the effect of, like, it didn't work, so I don't like it. That's a valid opinion. So
okay,
yeah, if it didn't work, don't sweat it. That was a long answer to a simple question. If it didn't work, don't sweat it. You're fine. You'll be using the workbench for the rest of the 13 weeks at this point.
Okay, teacher. Thank you.
No problem at all. Any other questions about week 1? Questions about week 2? No. All right. So the first thing, let me share my screen again. Okay. So here's what we got for week 2. We're talking about January. So let's see. In week 2, we're going to talk about all these clauses. I'm gonna in a few minutes, I'm gonna go through a bunch of, I'm gonna take you through some SQL, talk about the anatomy of the SQL query, how a SQL query actually runs, what the engine does. Like I said last week, I get into a lot of deep dives with how the engine runs, because I find just how I keep referring to this to an engine, and it is, because this is something that's running on your computer, independent of the operating system, and it's consuming resources, it's doing things, and it's constantly running behind. So it's an engine. It's also, database is also referred to as a platform. I don't know if I said this last week, but there was a point in time where Microsoft was actually looking to make a database operating system where Microsoft SQL Server would have actually been a legitimate operating system that you installed, and that's all the server would do. But they opted against that. I don't know why, but because I don't work for them. But so, okay, so we're gonna talk about this today in class. Your reading assignments, again, make sure you look at the PowerPoint slides, and make sure you look at all of these, because these here, right here, are going to be key if you want to do the final project. Because you need to talk about what a relational database model is, how to, and I will show you guys how to reverse engineer a database in a couple weeks. We'll talk about that, because you're going to need to learn how to you can take, if someone gives you an ERD, entity relationship diagram, you can load it into the workbench, and you can reverse engineer it back into the code. So we'll talk about that, but these are very important. And then you've got your tasks. We're going to talk about that. So yeah, so that's what it is. It's a pretty lightweight. The one that's going to freak everyone out, and has always freaked people out, is the video. And someone, I don't know if it's from this class or another class, pointed out that it says for you to write a 5 to 10 minutes video presentation. I'm not sure you're supposed to write a 5 to 10 minute presentation. But just as a reminder, the reason why we do the video presentation is so we don't have to use Proctorio. If we don't do this, we have to use Proctorio for the exams, which is no fun. So we're doing this to make everyone happy, to check that box off for the university, make sure that it's actually you doing this stuff. And this is kind of a neat way for you just to, because you don't have to do any written work, you just have to explain to me. And I'm gonna go through and do like another. I show you an idea of what I'm looking for in the video, and then we'll get into the code from this week, so you guys we can talk about the anatomy and stuff of T-SQL codes. So, any questions to this point?
Yeah, our video is gonna be just kind of like the video that was on it, right?
Yep.
Like,
I haven't watched that video in a couple of years, but probably yeah. Yeah. For me, all I want to see is I need to see your face, and then you just say, here's a website. Here's how I think the back end runs. You know, if you want to draw a picture, that's cool. If you don't want to draw a picture, this is just like step one in you guys understanding how the back end works, how a database is formed, how entity relationships between tables are done. And believe me, between now and week 12, we will be talking about this a lot. I'm gonna, not next week, but the week after, we'll probably sit down and design a database from scratch together, just so you know the flow and how it works. And you'll hear me use the word flow when it comes to data, because data flows. It's like water, okay? Because it's got to go through multiple tables and multiple queries and multiple indexes out to the end user, and it's got to be in a way that they'll understand. You know, it's like probably no one here understands how electricity gets to the outlet, because I certainly don't. It's not something I've ever thought about, but there's a huge process to get energy from the power plants through the capacitors and the transformers and all the other things to working when you plug in your phone. And forget about how the internet works, because that's just a whole other thing that is super confusing to me too. But so that's the background stuff that, you know, just look, YouTube works, yay. But how did it get to my phone? I don't know. But that's kind of like with databases. You guys need to start knowing how the sausage is made, for lack of a better term. So we're going to talk about that quite a lot. So with that being said, so let me go here and say, I have the Airbnb website up here, right? So if I were doing the presentation for my teacher in the class, I'd be like, hi, my name is Brother Stevic. This is from my reverse engineer a website. And so I'm going to use the Airbnb website because it's something I use often, because I travel and I find great deals to stay out of town. But looking at the prices now, man, that's changed. These prices used to be $100 less. So maybe traveling isn't so much in my future. But so if I look at this website, I see the first thing I see here is the date and how many guests in the map area. So I'm going to guess that there is a table that is probably called something like rentals. And in there, it has all the rental information, like address, how many people, how many bedrooms, things along those lines. There's probably another table somewhere that has dates that tells you when the house is used. It's probably not in the same table, because that doesn't make a lot of sense, because I read about normalization, and I know that the first rule of normalization is information in a table should only deal with what that table is about. So if I've got a table that's for rentals, the dates of rental are not, they don't directly address that table, so it'll be a different table. So it's probably a table for rental dates. I'm not sure how they connect together. So that's the two big things here. So I can do a search here, map area. I can say I'm going to go to, I don't know, San Francisco, California, and then I'll choose these as my dates. I'm going to have 3 people with me in that search. So somehow this is going to the locations table based on the city, and then the dates, putting that together. So that's one part of it. But also over here, I've got a filters. So I have other filters I can use. So I've got a price range. So there's probably somewhere, I would guess that's probably something that would be in the rental table of the rental information, how much it costs to rent it. So that's probably in that table. So that's probably there. Type of place, entire place, that's probably a separate table because there might be very many different types of places, and so and then rooms and bedrooms, that's probably in the initial table because that would deal directly to the property itself. So number of bedrooms, number of beds, number of bathrooms, that's probably in the original table. And then looking here, whether it's a house, apartment, guest house, or hotel. Okay, I'm gonna guess that's a separate table. So we're looking at now, we've got a property table or rental table. We've got a dates table, and we probably have a property type table too. And then amenities is definitely its own table because wow, there's a lot of these things here. So probably have a table that holds all the possible amenities, and somehow that table connects to the rental property table. We can get all those amenities there. And then, yeah, so this is another table. So the booking options would be another one. That'd probably be a separate table. Accessibility features, that would probably be a separate table. So we're up to like 4, 5 tables now. We've got the rental property, the dates, the amenities, the type, and the accessibility. So that's probably what we're looking at. And so I'm not really sure how they're going to link together because I'm really kind of new at this. So, but I can identify the individual tables. And then there's almost definitely a table that deals with the hosts, because one host can have many different properties that they rent. So they just have a host table as well. And then the host will speak a different language. So there's probably a table for the language that hosts speak. So that's another thing. So yeah, so we're looking at just initially from this one page, we're probably looking at 7 or 8 tables just on the outside. And then there's probably a way to link them. So there's probably a way to take the rental table and connect it to the host table, so we know which hosts own which table, which property. And there's probably a table between them, something like that, because one host might own multiple properties. So I can't really just put a host name in the rental property, because I mean, how do I know if they don't own multiple ones, or maybe more than one person owns it? It gets kind of confusing. So that'll go that way. Okay, so that thing. Okay, that's what I got. Thank you very much. And that's my assignment. So that's pretty much what I want to see from you. I mean, if you want to get through the process of drawing it out and kind of like, at some point I will get out, I'll be very technically savvy and I'll break out MS Paint and I'll use that to draw things for you guys. I think as we did last week, when I teach this in person, I got to make sure my classrooms have multiple dry erase boards, because I'll draw on all of them around the building. So that's what I'm looking for. I just want you guys to start thinking how the databases are formed. I just need to identify what tables do you think exist in the whatever, and it can be whatever website you want to do. Don't do Amazon. Someone always tries to do family search. Don't do family search. Don't do the church website, just because they're too big. There's too much going on there. I mean, I once tried to reverse engineer the church back end, and there's just a lot going on there. Particularly when you deal with login information and stuff like that. It's immense. You know, find a smaller website just for a business, something simple like, you know, for national parks. That's not going to have a huge infrastructure behind it. Amazon, eBay, anything like that, their infrastructure is gigantic behind it. And you will go down a rabbit hole so fast and get overwhelmed and confused. Trust me. I've seen it happen a lot. So just find something simple. Give me 5 minutes of a presentation, showing me that you kind of can see where the tables are going. I'll comment on it. And then, like I said, in the coming weeks, we will spend a lot of time on database design. The majority of our Wednesday nights will be about half for the first until week 9, about half on the code that you guys are doing with code examples. And then the other half will be about designing databases, understanding table structure, understanding indexes, how things work. And then, like I said, that week 10 on, we'll just solely be talking about people's projects. And we'll have a little we'll have brainstorming sessions on people's projects, help them out, discuss things. I'll troubleshoot, give suggestions on design. This is really more of the final project for me is more of it's not necessarily a group project because everyone's got to turn in their own, but I want to make it more of like a community effort, because if we have the examples, if everyone here, if all 11 people here tonight do the project and show up week 10 and on, we'll go through 2 or 3 of his projects, and the person who we're talking about specifically will get helped out, and they'll learn and see the way their data needs to flow, and the database and how the tables are going to be built and how that organically will come. And then those who are just watching are going to learn because they're going to see what's being done on another database, and they'll be able to take that and bring it to their own database. Okay. So any questions on reverse engineering your database, the assignment, the video assignment from this week, or any questions on database design in general that we can attack right now? All right. Cool. So without further ado, let's talk about queries and anatomy of the query and all that really fun stuff. Okay, so last week we talked about the DM, we talked DDL versus DDL versus DML. DDL is data definition language. It's create, modify, and drop. Those are the 3: create, modify, and drop. Data definition language are what create the tables, the indexes, any physical structure that holds the data or directs the data. Okay. Tables hold data. Indexes sort data. Queries direct data. Okay. Those all are stored procedures, direct data. Those are create, modify. They are permanent structures within the scheme of the database that house, direct, or organize data. Okay. DML, data manipulation language, is select, insert, update, and delete. They're how we change the data. They're how we pull the data out, we modify the data, we put the data back in. So that's what we call it, data manipulation language. There are other ones that we'll talk about, DSL, data secure language, and a couple others, but the only 2, I think it's this week's quiz or next week, so they'll talk about the other ones. But those are just quiz questions you need to answer. As far as practical, when you leave this class, you know what you're doing, you need to know DDL and DML. Data definition language, create, modify, drop, creates the structure of the database, the housing, organizing, and transmission of data. And DML, which is data manipulation language, select, update, insert, delete. And those are how you massage, insert, remove, and present data. Okay. So I've got a couple of queries here, and we're just going to go through them really quick. I'm going to talk about them. And the great thing, I think I brought this up last week. The great thing about T-SQL, transaction structured query language, that's what it is. Every database, be it Oracle, be it MySQL, be it Microsoft SQL Server, be it MongoDB, be it what else? MariaDB, Cassandra, any of those, they all use T-SQL. They all speak the same language. Anyone who's in a development course, you've got C#, C++, Java, J#, JavaScript, HTML. There's 1,000 different programming languages, and they don't talk to each other. They're not universal. And in your more robust real, it's not MySQL, like your Microsoft SQLs or your Oracle, you can actually write queries in C# and J# and stuff like that, but that's just showing off. T-SQL is English. It's just, here's what it is. So my first query is select first name, last name from customer. So here's my customer table. And I think I said this last week, note that all the table names, except for this one that I made, all the table names are singular. Okay, it's not the categories table, it's the category table. So just be when you build databases and you create tables, remember that the table name is always singular, it's never plural. So select first name, last name, customer. So what am I doing? I'm asking the query to get me the column first name and last name from the table customer. I mean, it's English. So if I do this and I run it, it gives me my answer. Okay. This is the same one. I don't know why I put it there, so get rid of that. Okay. Now, also tonight, I'll be covering things from future weeks. So what I'm about to show you is not until week 5. So we've got this command here called concat. Concatenation is one of my favorite words. I just like saying concatenation. Concatenation or concat all it means is taking 2 strings and jamming them together. So my concat command, I'm doing the same query as here. Select first name, last name from customer. But here I'm doing select and I'm doing concat. And in parentheses, last name, comma, quote, comma, quote, and then comma first name. So what I'm saying is when you return this to me, right? When you return this to me, when you see here, this is 2 different columns, right? I got a first name column and a last name column. What I want both in one column separated by a comma that shows me the full name in one column. So when I run this, that's exactly what happens. So I've got, now this is a way that I want to present the data to the end user. I want them to see this. This is how I want to see it, right? Now, you'll notice something here. When I did this, I had my column name was first name, my column name was last name, because that's what's here. First name, last name. When I did this, my column name was concat first name, comma, the column last name. That's my column name. That's not a good column name. We don't want that to be the column name. That's not pleasurable. That's not, no one's going to understand that. I've got an as clause. And when I use the as clause as part of the select clause, it will rename the column that is just in front, just behind. So if I run this, I'll get the same result, but that column is now going to be called customer and not what the query was. Okay. And all this code will be in the, when I post the video, all this code will be in that announcement, so you can grab it from there. So you don't need to try and copy it down as you go along, because that's just wrong. So here again, and now I've got a thing. I've got a new thing. I've got order by. I'm ordering by the last name. Here, there's no order here. Here, I'm ordering by the last name. So I'm telling the database, please go get me the last name, first name, put them together and call them customer, put a comma between them from the customer table. And then if you wouldn't mind, please order it by the last name. Now here, I'm adding another column, store ID, concatenating the first and last name as customer from customer, and I'm ordering by the last name. Same thing. Now I've got this and all the store IDs, all right? Here, I'm going to do the same thing again. Put this as customer. Keep going on this. Okay. But now here I'm saying order by store ID and then order by last name. So what's going to happen is it's going to order by the store ID, and then it's going to alphabetize based on the store ID. Same query as before, just we're sorting it differently. And we got store ID number 1, Abernathy, scrolling down till we get to store number 2. And there's a lot of fields here. So we get to 2, we're back to A. And here's store number 2, Kathleen Adams. I can go here and add a descending comment, which means it's now going to go last to first. And 2's in front. By default, it's ascending, A to Z. If you use DESC, it doesn't stand for description, it stands for descending. It goes Z to A, or 1,000,000 to 1, or 1 to 1,000,000. Everyone with me so far?
Stevik, does
Yes.
that descend apply to both the last name and the store ID when you write it that way?
Well, look, which one is it? Which one is it applying to? Because here's the results. It's only to the store ID. If I wanted to apply the last name, I got to add it here too.
Okay.
And then it will apply to both. And if I remove it from here,
And it goes back to ascending.
it will, when you use ascending and descending, it will only apply to that which immediately follows before the comma. Everyone doing good? Everyone follow me? Everyone keeping up? Am I going too fast? If I'm going too fast, let me know. I'll slow down. Because I enjoy talking about this stuff, and I talk fast when I enjoy things. Okay. Looking good. All right. So next, we're going to add a where clause to this. So now we've got, give me the store ID and concatenate the last name and first name from the customer table, but only where the last name is like D. So wherever the last name starts with D, give me that. And then order it by store ID and last name. Which means this is going to be much shorter and a much easier order because we're only doing D last names. So if I run this, I got an error because I took too much with it. If I run this, there we go. Same thing, but now it's only giving me the last names that start with D. And if you look down here, you'll see how many rows were returned. So there's only 17 rows returned as opposed to 600. Now, what else can I do here? I can take this. So the percent sign is a wildcard sign. Okay. So what that means is give me something with D and anything that follows is fine. I can do this. Show me anything that ends in D. And I run that. And now I'm only getting last names that end in D. Okay. I can also do this. Show me any name with last name where the D, it just has a D in it. And I'm going to show all these. It can be the first letter. It can be the last letter. Just if there's a D in that last name, I'm going to see it. And we have 107 rows returned on that query. Now, there's a couple of clauses here that we did once. So we got the where clause, right? But we also have this called the like clause. Whenever we're doing comparisons that are not specific, we use like. If I wanted something specific, I would use equal. If I ran this, nothing would happen because I've got nothing percent sign, D percent sign. That's exact that. Equal says, give me the exact thing returned in that column. Like does that. Now I can also add this and say not like. What do you think that's going to do?
Anything without a D in it.
Go ahead. Jason, who else spoke?
Anything without a D in it.
Anything without a D in it.
Yes.
So the other person who spoke was going to return. So I do this, no D in the name. 492 rows are returned. Okay. So, and we're doing the order by statement. So we got where, got like, not like, equal. All right. Now here. So now we've been doing this store last name, and I need to show you this because it's brought up in your quizzes, text, and everything. The order by, we're using numbers. So now this is called cardinal sorting. Okay, I do not recommend that you use it outside the scope of this class. Because it will confuse a lot of people. This is how coding happened back when Moses was doing the coding on the tablets. Okay, we don't do this anymore. Basically what you're saying is it's the same query. You're saying order by 1, then 2. So 1 is the first column that's requested. 2 is the second column. Now, because this is a concatenation, that's the second column. So this order by clause and this order by clause are exactly the same. Just this one is easy to understand. And you use this one when you're afraid you're going to lose your job and you don't want to understand your code. Okay. All right. We're going to go into some more advanced stuff here that's not for till week 6 or 7. Everyone good? How we doing? Anyone's brain full? All right. Moving on. Now, and I bring this up now because this is advanced, but we're going to talk about aggregations. And I bring this up now because by the time they come around in week 6 or 7, you will be doing this the way you're supposed to and not running into the common errors. An aggregation is whenever you're dealing with numbers. Okay. So in this first query, the first aggregate is called count. So I'm taking select the rating and count from film. Now, what this is going to do, does anyone want to take a guess what this is going to do?
It will return the like only one value, the count of all of the it will tell you a list of all the films and the count of each rating and
Exactly.
how much
Exactly.
and what is the rating for each of those films.
Exactly. So what that's going to do, it's going to show me the rating and then how many films have that rating. You're exactly right. Great. Weighty, right? So I say weighty.
Wadi.
Wadi. I was close. That vowel always gets me. Wadi. All right. So this query is going to show me the rating and then how many films have that rating. Okay. And the reason it's going to do that is because of this called the group by. I'm going to say this 3 or 4 times tonight. I'm going to say it 2 or 3 times in subsequent weeks, because this is the most important thing in my 7 years teaching this class, the one thing that students forget the most. If you are using an aggregate, you must use the group by clause for anything that is not in the aggregate. Okay? If you're using an aggregate, any column not in the aggregate must be in the group by clause. So what's going to happen here is you're going to run this. So you give me the rating and the count from film, and then you're going to say, make sure you group it by this column so it knows how to count them. So if let me run this correctly here, and it shows me there are 178 G movies, 194 PG movies, 223 and NC-17, right? So that's my aggregate. So I know how many I have. If I take out this group by clause, this is what it looks like. That's not right. It goes with the first one so it'll go with the first one, and order by PG is not the first one. It's going to grab the first one in row 1 of your table and then put the count at that. So that's why this is so important. Okay. So what count does is it gives you how many of each occurs. The next one is average. I'm going to get the rating and the average of the length. It does exactly what I think it's going to do. It's going to look at all 178 movies that are G and give me the average length of the movie.
So I have a question real quick.
Sure.
Sorry. So with the count aggregate, if you take out the asterisk and you put G in there, will it only bring up the G movies, or do you have to do something later on with like the order by or something do a like statement to get like just the G or the PG movies?
It's a great question. And let me show you that. So first of all, if I put a G in here, would it work? No. And the reason why is because this asterisk is replacing the name of a column. Okay. If I just put G there, and run this, it just gives me that. Okay.
Okay.
So what I would have to, the asterisk would get replaced by a column name if I want to do a column, a specific column. Now, if I wanted to, I think it was here. If I wanted to get the G and PG movies anywhere, and thank you for bringing this up because I forgot this one in the clause. There's another clause where rating is not like, and it's not equal, it's in. And then I can do this.
Why will equal not work in this case? Because it's not a value or something?
Because there's more than one value. Because I've got
Oh,
two
because
values
you
here.
want G and PG, got it.
Yep.
If it was only G, then you could use equal.
Yes, correct. But because there's two values in there, it's not going to work. Okay. So if I put equal here, it should give me an error. I wonder what it's going to do if I do. Let me run it first the right way. And it should give me those two. I can also do this. And it's going to do what you think it's going to do. So everything's not PG.
Could you do equal G and equal PG, or that's not a thing?
You could do this.
Okay.
Okay. Now, I got no results there. Why?
Because
Because
you
of
need
the
an
group
or
by?
instead of the and.
Because I need the or instead of the and. Exactly.
None of them are going to be G and PG.
Exactly. Exactly. Very good, Mark. So here's the thing. So because I put it and there, I'm saying show me all the columns where rating is G and rating is PG. That can't exist. It'll never be that way. So I can put the or here. And then do that. And I'll get my results back. Now, the only reason I would really do it this way is if this was a different column. So I could do this. Film, where my columns are here. Okay, where? Title. Like. Take. So now what this query is going to do is going to be the rating and the count from film where the rating is G or the title is like T. So my numbers change here. So I've got.
And you can include the column of those titles as well, right? Like in the top in the select.
It does. So I could put it here too. Okay. But I don't need to. So I did this way specifically. You can put stuff in the where clause that's not in the select clause. They're mutually exclusive. I can put anything I want in the where clause, anything I want in the select clause, because this is I'm asking them to show me this information, and this is how I find it. So they don't necessarily, the query doesn't have to have the results of how I found it. I just need the results of that, right? So when I run this, I say me show where G, rating is G, or where the title is like T, right? It's still grouping by rating. So I've got 178 G-rated movies, and I've got 14 PG movies that start with the letter T. Because I put the or there. Does everyone follow me? If I put the and here, it's going to show me all G-rated movies that start with T. So this is going to look a little different. There are only 9. That and or are very powerful. Everyone following that? This is actually the deepest I've ever gone in a week 2 class, so this is exciting for me. Is everyone doing okay with this? Okay. So yeah, so now if I'm going back to here, if I want to do multiple ratings, I'm going to do the in statement, the in clause, because it's just cleaner. Right? But I can also do an and. Okay. Okay, so we've got count as an aggregate. We've got average as an aggregate. We also have max and min. So here I've got select rating from film. Give me the maximum replacement cost to replace a film. Give me the minimum replacement cost to replace the film. We're going to group it by rating, and we're not going to sort it. Okay. Okay. And down here I've got one where it's like select title from description, where from film, where descriptions like docu and description like cow. So I'm looking for in description where it's both that's in a word and that's in the word in the description. No, these are always about a documentary about a mad cow. The lackluster documentary of a mad cow and a madman who must sink a moose in the Gulf of Mexico. I'd probably watch that movie. An emotional documentary of a moose in a car who must redeem a mad cow in a balloon factory. All right. It's next week's, that's next year's Disney Plus. Anyway, sorry, I digress. Okay. Now, the last thing I'm going to talk about is something that we'll talk in great detail in week 5. And this is when we're joining tables together. But I want to talk about it now just to give you guys a start. So when you start, if we talk about it now, we talk about it a little bit over the course of time, you get more used to seeing it. And there's this command inner join. So this is connecting 2 tables. Whenever you use the join command, you're connecting multiple tables. So in this query, I'm joining the film table and the language table, because the film table has a column called language ID. Okay. And there's a language table that has a column, language ID. So this ID we find in here. So what this query is going to do, it's going to join the film table with the language table on this column, on language ID column. And then it's going to show me the name of the film, the rating of the film, and why am I not? Oh, I want the language here. Give me here. Name. Okay. And then the count for the rating. I haven't held on. Okay. So now let's break down the anatomy of this real quick. You'll notice here I have a letter after the name of the table. That is me aliasing that table so I can use it in the queries. When I'm doing this, see, I've got L. Oh, I did it wrong. I have it all wrong. Okay, I did that back. So here I've got select L name, F rating, and count for F rating. This is saying, hey, get the name from the language table, get me the rating from the film table, and then give me the count of the rating from the film table. So this is that question before where someone said, what you're gonna replace the asterisk with here? So I'm telling you to give me the count of the F rating table as opposed to the L name. Okay. I need to put this in front of the column name because I need to tell the query what table to look at to get the column from, especially if both tables have columns with the same name. Make sense? Everyone with me? Okay. So getting the name, the rating, and then the count of the rating from film, joining the language table where language ID is the same. I'm grouping by last name and rating, and the name and rating, because these two columns aren't in the aggregate. This is the aggregate. This is what's not in the aggregate. And I'm ordering it by rating and last name. Not last name, but ordering by rating and then film name. So I'm going to run this. So in English, with a rating of G, I've got 112 films. In Italian, in G, I've got 39 films. And in Japanese, in G, I've got 27 films. Does everyone follow that? All right. So the last thing I'm going to talk about in the last 7 minutes, but we'll probably start running a little bit late tonight, is I'm going to talk about, and this is brought up in one of the questions. Someone, I think Mark, you sent me a question about this because the book and I disagree on something. And I didn't make the quiz. And I don't know why it doesn't come this way. So for those who haven't gotten this far, when you're looking at a query like this, the first thing that the engine runs is the from clause. So here's the important thing you got to realize about databases. You cannot change, manipulate, or look at data that is on the hard drive. Okay? Data cannot exist on the hard drive for you to use it. It must exist in memory. Because memory is volatile. Hard drive is solid state. You can't change what's there. You can't manipulate, you can't mess with it. It's got to come into memory. So whenever you're running and this is why you've got to really be really aware of what you're selecting and how much memory you've got on your box, right? Because if you're pulling in data from a database that's, I don't know, 500 gigs of data, and you've only got 128 gigs on your laptop, you're going to have a problem. It'll work, but it's going to work super slow because it's going to start paging data. So you need to make sure when you write these queries, so everything brings data over. So when you write this, the first thing that happens, it takes everything in the from clauses and puts it in memory, the entire table. Okay. In this case, it'll use the on clause as well, because that's part of the from. The next thing it does, if you look up here, it does the where. So what it does, so it does the from, and then it looks at the where clause and gets rid of anything that doesn't fit in the where clause. Then it does the group by. And then it does the order by. And the last thing it does is this. Because it can't do this until everything's in the proper order and been massaged out and messed around with, and because this is just taking what's in memory and spitting it to the screen. So the way you write it isn't the way that, and the truth is, if you want to get really technical, it converts this into machine code that you wouldn't even understand to look at. Right? And when it returns to machine code, that's the order the stuff goes in. That's how the engine does it. So I forget if, I think the book says order by is the last one to run, which isn't correct. It's select that runs last. I forget what, Mark, what was it? Was it that order by, it said order by ran last or? I can't hear you, man. Nah, it's still not working. I don't know what's going on. Can anyone else hear him? Just me? No, not so. I'll look it up. I'll see what it is because I have your email that you sent me, and that's fine. Anyway. Okay, so that covers everything I had for tonight. Oh, we should chat. Let's get something to chat here. Sorry, I gotta go, kids. Okay, bye, Maya. Well, she's already gone. Sorry. Bye, Maya. If you're watching this, see ya. Sorry to leave early. Does everyone kind of understand the anatomy of the SQL queries? Because everything just comes off of this. They just get bigger and more complicated after this. There's nothing. You add more clauses to it, make the clauses more complicated. There's more aggregates, there's more concatenations, there's more things that you can do to massage the data out to where you look at it. But this is fundamentally every SQL query looks like that when you get down to where it comes from. Okay. So that ends my agenda for tonight. Does anyone have any questions, comments, thoughts, queries? No. All right. So what I'm going to do is I'm going to convert this thing and put it up on YouTube like everything else, like and subscribe. And I'm looking to get 40 followers by the end of this semester. It's very exciting. I'm at 27 now. Woohoo! I can monetize in like 18 years. But I'll put this on there. I'll put the code in here. The code you saw here, I'll put in the query in the announcement. And like I said, this is really where it all begins. Understanding how the code works. When you're talking about DDL, creating the tables is a whole different structure and flow to that. But there's a super easy way to cheat that out, so you never actually have to write the code. And I'll show you guys that later. I think I showed you guys over here. I'll show you again. Like with this, you can right click here and send to SQL editor, and then it'll write all the statements for you if you don't want to write it. If you want to write select an insert statement, it'll just write the insert statement for you. And you just can fill out the blanks. This will come in handy if you're doing the project. Because it'll save you a lot of typing. But yeah, you can pretty much go here. You can script out the create statement or all this other fun stuff. You do create table like this one. So anyway, it's 10:30, so I'm gonna call it here because it's 10:30 my time. I don't know where you all are and how late it is by you. But all right, if there's nothing else, thank you for coming. I will see you guys next week, and you guys know where I am if you need anything. Bye, guys.
Thank you.